For my physics project, I did the physics of Mr. Incredible throwing his boss through the walls of his office. The purpose of my project was to determine if it was physically possible for Mr. Incredible to throw his boss, Mr. Huff, through the four walls of his office. The things I needed to know before I got started were the fact that Mr. Incredible has super strength, so he is stronger than normal people. Mr. Huff is thrown through 4 office walls. Each of them have 2 layers. And Mr. Huff ends with excess velocity. The 4 layers the 4 amounts of walls are shown here with the arrows, and it's also obvious because there are 3 people in between Mr. Incredible and the last wall he broke through, meaning that there were 3 offices plus the wall of Mr. Incredible's office, meaning that there were 4 walls altogether. And if you look closely, there are 2 layers for each wall. This is likely because generally in offices the walls are fireproof, which means that they are thicker than normal, and I believe they're about 5/8 of an inch. Anyway, and then the excess force is shown in this video. Where he hits the locker, meaning that he had enough force to break through the walls and continue going. The data I collected is that Mr. Huff's head circumference is about 52 centimeters or 0.52 meters. I estimated this amount based on the facts I found about the size of a 10-year-old boy's head, because Mr. Huff is roughly the same size as Mr. Incredible's son, Dash. And Dash is about 10 years old. So assuming they have the same head circumference, Mr. Huff's head is 52 centimeters in circumference. And I estimated his weight to be about 90 pounds because the average 10-year-old is about 60 to 80 pounds. However, since Mr. Huff is an adult, he likely weighs more. But due to his build, he is not very muscular, so he's probably not very dense. Also, if I estimate a lighter weight, it is more likely for it to be possible because lighter objects are able to gain acceleration quicker. I used a height of 4 feet, or 1.22 meters, for Mr. Huff's height, since the ratio of Mr. Huff to Mr. Incredible is still roughly 60%, which is realistic based on these images of Mr. Huff next to Mr. Incredible. And Mr. Incredible himself is about 6'7" or so, maybe a little bit shorter. Anyway, when I analyzed the data I found that the radius of Mr. Huff's head is about 8 centimeters using the circumference I found earlier, and the fact that circumference is equal to 2 pi r. And then I used the radius to find the area of Mr. Huff's head, which came out to be 0.2021 meters squared. And I used the equation that area is equal to pi r squared in order to find that. And then to find the force, I multiplied the area that I found times the pressure that I found, which is needed to break down the walls. And it came out to a force needed of 59,173 newtons, or rounding 59,174 newtons, which is an incredible amount of force that obviously no person could exert, but because he's a superhero, we'll say that this might be possible. To solve for the acceleration needed, I divided the force by the mass that I found for Mr. Huff, and the acceleration needed ended up being 2,192 meters per second squared rounded, which, even using the larger mass, it's closer to 2,005 meters per second squared. However, even despite the fact that Mr. Incredible has super strength and is therefore stronger than the average human, I ended up coming to the conclusion that it would be impossible for him to break down the walls with Mr. Huff, because Mr. Huff would not have enough time to accelerate to the needed acceleration due to the fact that Mr. Incredible is also like standing really close to the wall. So even if Mr. Incredible is able to exert the force needed, I don't think he would be able to get Mr. Huff's acceleration high enough in order to break through the four walls, especially since he still has excess velocity at the end.